Okay, welcome everyone. Good morning. Good morning. It is absolutely thrilling for all of us that have been working over the last few months to prepare for this workshop, and having such a stellar group here is really reinforcing to the mission and objectives that we have for coming here to the National Academies. My name is Joe DeSimone, and I'm at the University of North Carolina at Chapel Hill and North Carolina State University. And I want to welcome you here to the workshop that we have on the key challenges for the implementation of Convergence. I think it's clear that many of us, down to our souls, believe in the value of Convergence and what it can bring. In fact, like many people have said, it's indeed a roadmap for innovation. And that is critical for new knowledge, that's critical for the training of new students, that's critical for our economy and improving the health and well-being of everybody. It's absolutely important. And so this workshop in particular is extremely important because we all also believe that we're not able to maximize all of the talents that we have because there are a number of roadblocks that we struggle with in trying to implement convergence and have a culture or ecosystem of convergence. And so this meeting, this workshop, is really to focus on those issues that we have tried that seem to be working on implementing convergent-like strategies and facilitating convergent-like culture. Also to identify some of those things that people have tried that may have not worked, or some things that maybe work but if only, and then complete the sentence. If only something else just put us over the edge. And to think through all of those so that we could come up with ways to unlock the power of convergence that we all believe in. At the same time, we also recognize the importance of disciplinary learning and science. And so we're not advocating that everyone operate in this mode, but the importance of this mode in conjunction with the traditional mode is very important to all of us. So we've brought together, as you can see from the participant list, an incredible range of people that represent luminaries in research that embody convergence. We brought together university administrators and leaders, leaders at funding agencies, leaders at think tanks. We brought together students and faculty. We brought together industry, folks from large major research universities as well as those at residential liberal arts colleges. And so it's that broad perspective that we all are struggling with at times, but also appreciate the value of convergence strategies. And so, a lot of us are firm believers that diversity is a fundamental tenet of innovation, and the perspectives in this room are really critical to get out on the table so that we could capture those and help facilitate what we all do here. And so through discussion and presentations, we really want to try to grab some of these key issues going forward. And we started to think last night at our dinner, the organizing team, about what are some of our aspirations for the end of this meeting. And we've been talking about this for a long time. But as you can imagine, it's going to look very challenging because we do have a lot of different types of organizations, and there's probably going to be very few strategies that transcend all of them. But there may be some. But we need to think about, what everything's going to be local in a lot of ways so that we can scale some of these characteristics that we're learning about. So it's going to take a discussion. It's going to take people feeling like they're emboldened to give us their advice. And what you have in your packets is certainly a lot of note paper available at the end so that you can write things down. We really need to capture your thoughts going forward. The breakout sessions, we're going to have report outs, and we'll have people there to help facilitate the capturing of the ideas. So that's going to be an important component of this meeting. And then at the end, it's going to be very important for us to sort of coordinate the ideas that come forward and really want to get everyone's help in doing that. So welcome. We're excited to get launched here. And let me hand it over to my colleagues here for introductions. Ralph?
Thanks, Joe. I was just leafing through the blank pages at the back. I didn't know they were there. The workshop booklet, I think, bears out what Joe DeSimone just said, that this is really a stellar group. And we're just very pleased that everybody could be here at all, let alone at this hour of the morning. I know the meeting, the schedule was hard to arrange. A number of you on the organizing committee had to work very hard to keep these dates open in the interest of having the right location and to get the kind of participants that you want. So thank you for doing that. But I think it's clearly off to a stunning start when you look at the array of people who are here and the topics to be discussed. And it's a compliment to all of the organizers. Thank you. I'm reminded of a phrase that I came across a long time ago. I think I was a postdoc. There was a competitive Frisbee team in Ann Arbor. They called themselves the humbly magnificent champions of the universe. And I've never heard those words strung together before, so they've stuck. And when I look at the list of topics that you want to take on and are already taking on in so many different research institutions and universities, it is kind of a humbly magnificent agenda, if you will, to take on really large issues and questions, especially in basic biology and biomedical research, all the way from the molecular and the genetic through to organismic and behavioral issues. And there's only one way to do it, and that's to bring everything together. And I don't know who coined the term convergence. Phil, was it you? Thank you. It's a good one. It doesn't have all the pizzazz to it, but it certainly describes what's going on. But in a way, it's the kind of approach that a beginning student would take in thinking of some of the fundamental questions that all of you have in mind. That is, a student who had not yet been exposed to the individual disciplines and all the specialization which we've learned to appreciate and we always dig deeper into. So the questions are humbly magnificent, and I think the approach is very amenable to attracting students because that's the way they thought about things before they became individual specialists. We had a report come out of here 3 or 4 years ago, A New Biology for the 21st Century, that Phil, I think you and Tom, is it Conley, out of DuPont, chaired. And they chose to emphasize a bunch of wide-ranging and in some cases real-world applied problems. And one of the reasonings that they had in placing that emphasis on the New Biology for the 21st Century report was that it does appeal very much to students and young people who are going to have to face a world even more challenged with limitations and capabilities than we are. A lot of people have been preaching for a long time the need to work together and do things in an interdisciplinary and multidisciplinary way. And of course, there's a lot of truth to that, but doing this all the right way with appropriate depth is difficult. One example where we've really had some fun, and I think have contributed somewhat across the National Academy of Engineering and Institute of Medicine and National Academy of Sciences, is through something called the National Academy's Keck Future Initiative. And I see Dr. Pellegrini here this morning. This program has been going on for some years now, where a topic will be chosen which literally does cut across and involve many disciplines, and then to assemble a group of people who've never met each other professionally or otherwise, usually, to do a series of tutorials about where they're coming from, and then take on really major issues which are just inherently, innately, if you will, multidisciplinary. And at the end of those meetings, typically, people are forming long-term collaborations with each other. They've issued patents. They started new areas of investigation. And the program's been very successful. So we know there's a hunger out there for this kind of work. So we're really looking forward to hearing what you come up with, both on the educational and pure research side. It was a year ago this month that I was present at some conversations that a few of us were having with a group of U.S. senators, and Phil Sharp, towards the end of the meeting, brought up a couple of issues like these, having to do with the kind of educational background and attitude needed to do advanced biology today, let's say in the minds of students and grad students. And that was the culmination of a very good discussion. I think it was someone else who joined you in that topic. It might have been Tom Check, but it came across very well. The senators were very pleased that leaders in research today are thinking ahead about how to make faster progress and deeper progress on really complicated problems without simply asking for more research funds. Although, of course, if we went back today 12 months later, we'd probably start with the research fund side of it. At any rate, there's a lot to be encouraged about. The participation in this meeting today and tomorrow is fantastic. We're looking forward to it. And Joe, thanks again for getting us started.
And our next welcoming message from Dan Moat, President of the National Academy of Engineering.
Well, thank you very much, Joe. It's my great pleasure to be here. When I was asked to come and give a welcome on behalf of the NAE, I immediately said yes, even before knowing it was 8 o'clock in the morning. And I'm especially impressed that all the seats are filled. I mean, this doesn't happen very often, as you know. So it really shows the high intensity of interest in this topic. Oh, the National Academy of Engineering, of course, has a very long-standing interest in collaborations with sciences and medicine. And in fact, if you look at its major issues, they're all multidisciplinary, as a matter of fact. So this is a very natural thing for us to do. And of course, as our learning and our knowledge advances, this essentially expands the platform, the foundation of our knowledge. That naturally leads to convergence as an outcome, because in order to take advantage of this knowledge base, you just have to be multidisciplinary, because that's where the knowledge is located that you need. So this is a very natural consequence of the progress of science and engineering globally. So I'm very excited about this idea. I had a little personal experience, but I could have used this workshop myself. A long time ago, it was in the 90s, there was a National Research Council study of graduate departments and stuff like that you know well how this works. And the thing that struck me at the time, somewhere in the mid-90s, whenever this came out, was that the bioengineering department in UCSF and the bioengineering department at Berkeley, where I was at the time, ranked 6th and 7th or something like that nationally. Now, it wasn't the fact of this low ranking, by the way, that caught my attention. It was the fact that neither UCSF nor Berkeley had a bioengineering department. I thought that was pretty interesting. Of course, there are joint programs, and there's a lot of bioengineering going on since the 50s, as a matter of fact, but there was no department. So I said to myself, whoa, we really ought to have, do something about this. So I set about this project, naively, of course. In retrospect, after a dozen years as president, I understand why it's so naive, but nonetheless, set about this project to create one department of bioengineering that would actually span 2 campuses. And so the faculty, the students, and the facilities of either campus would be part of this same department. And they'd have joint programs, and it would go like that. And everybody I talked to, by the way, all the faculty thought it was a great idea. In fact, no one said no. In fact, they said yes, with a big capital Y. And so I naively started off on this trajectory. And the whole thing collapsed, of course. But the reason it collapsed was not because of the content or not because of the interest of the students and the faculty, who in fact had been working together for a long time. It was because of the administrative structures of the 2 campuses. Everything was different. What the workload, what the student, what the degree, how do you give credit for this and that? Do you pay your faculty? Do they pay themselves? I don't know. All of these things stood against, in the whole university. We're not going to reconstruct the whole university systems for this one department. So, of course, there are other mechanisms one could have taken to not create a department, create a center or something like that. But it didn't quite fulfill, in my view, what needed to be at the core of the university, not an auxiliary to the university. And that's why this convergence idea and this workshop is so important, because these sorts of things can be aired out, and we can sort of move the administrative structures of these institutions, so in fact they can not only accept the idea, but they can embrace the idea of convergence very fundamentally. So I'm very, as you can tell, stoked about this plan. Now, the National Academy of Engineering, just to give you some ideas, I mentioned it was very multidisciplinary in its focus. It has, I'll give you one idea, 14 grand challenges. You know, they set about for the new century to figure out what are the big grand challenges for engineering in this century. So out comes these grand challenges in 2008, and many people in this room, by the way, participated in putting these 14 together. And just to give you some idea of what some of these grand challenges are, just not to give you a lecture on them, but just to give you, just by the titles, you can see. One of them is engineering better medicines, reverse engineering the brain, manage the nitrogen cycle, engineer tools for discovery. So these are all big multidisciplinary activities that fit into the domain of, very essentially, of convergence. Now, Ralph mentioned Keck Futures and their importance. I would like to just talk about a couple of other things that's in sciences and engineering. They're the Cobley Frontiers of Science and the National Academy of Engineering Frontiers of Engineering. These are programs that are focused on younger scientists and engineers, 30 to 45 years old. They are recruited from around the country. Say for engineering, it'd be about 100 people, young people. They come, they bring the frontier topic that they're working on, that they're excited about. Their colleagues do the same thing. They create relationships with them, even though they're coming from different domains. They create colleagues that will work together forever. And it's a way of kind of nurturing and building the next generation of leadership in engineering and sciences. This is an attractive program. People come to it. Foreign countries come to it. We have half a dozen bilateral international Frontiers of Engineering programs because it's an attractor and also it's an expander of engineering globally as well, and the NAE globally. So it's pushing the NAE out of the country and it's attracting people to it. So these programs are very, very, very successful. And the topics, of course, are multidisciplinary. You know, the 2013 U.S.-German bilateral Frontiers of Engineering topic was transport and complex systems. The U.S.-China Frontiers program, which was this spring, was biomems. The U.S. the Frontiers of Engineering this week at DuPont is cognitive manufacturing. Just to give you some ideas about this. Not a bad thing to build, by the way, while you're at it. This fall, right now, essentially, the National Academy of Engineering is also celebrating this convergence of engineering through life sciences in its internal magazine called The Bridge. This bridge is published quarterly by the NAE, and it basically highlights areas of engineering and research and developments and education for the membership, but also for other readers of the magazine, policymakers, educational leaders, and so forth. And it basically talks about the roles of engineering society. And the issue of convergence for this is that this fall's issue is really dedicated to convergence. And one of the guest editors of this issue, of course, is Phil Sharp, as you might not be surprised to hear. And several other authors are also in the audience as well. So convergence is going to be a feature of the Bridge magazine. So let me just close by saying this paradigm of convergence is not only exciting and fruitful, but it's actually necessary. I say absolutely, in fact, necessary to advance engineering and sciences in services of humanity and society. This has got to be done. And I know I speak for all the academies in wishing you very well on this and emphasizing the importance of this workshop and your work on this, because this is going to be the cornerstone for how it's going to go forward. Basically, not only from what you bring together and agree on, but also how you help promulgate this idea to the subsequent policymakers that are going to make this happen. So this is not just convergence for a particular idea. I'd say this is convergence for a continuing theme of how we're going to develop our academic programs in the future. So thank you very much for your efforts, and I look forward to your results.
Sure. Let me introduce Tom Khalil from OSTP. Welcome, Tom.
Well, good morning. In the hour that the organizing committee has graciously provided with me, I wanted to cover 4 points. One is why does the White House think that convergence is important? Second, why now? Third, what are some of the steps that the administration and individual science agencies are taking to promote convergence? And finally, what are some of the things that the research community might do to help promote convergence? And as some of the previous speakers have noted, convergence is important because there are a large number of important real-world problems that don't respect disciplinary boundaries. So whether you're talking about the ability to feed 9 to 10 billion people on a hotter, drier planet while reducing the environmental footprint of agriculture, or improving health outcomes while lowering costs, or directly attacking the mechanisms of aging as opposed to going after individual diseases of aging, these are things that are going to require a lot more collaboration between researchers in biology, the physical sciences, and engineering, and even in some cases, the social and behavioral sciences. And it's also important because I think convergence can create a virtuous circle of innovation. So if you think about the intersection between bio and nano, on the one hand, elucidating how Mother Nature does all these cool things like having diatoms that can produce exquisite silica nanostructures in seawater at room temperature, when that's something that requires engineers working at 900 degrees C. There's a lot that engineers can learn from biology. And conversely, nanoengineers are developing new techniques for targeted drug delivery or highly sensitive and selective multiplexed detection of biomolecules. So you can see by investing in convergence that we could create this virtuous circle of innovation. And there's also the opportunity for what Hal Varian calls combinatorial innovation. He says every now and then a technology or a set of technologies comes along that offers a rich set of components that can be combined and recombined to create new products and services. The arrival of these components then sets off a technology boom as innovators work through the possibilities. So if a lot of innovation is a novel combination of existing ideas, then getting researchers together who are exploring these different building blocks can be very powerful. This is a great time to be talking about this issue because there are a number of research universities that are making investments in convergence, whether it's new institutional practices like cluster hiring or multidisciplinary research institutes, many of which are represented in the room today, whether it's Stanford's BioX, or the MIT Institute for Integrated Cancer Research, or the Harvard Weiss Institute, or UC's QB3, or the University of Michigan's North Campus Research Complex, or the University of Chicago's Institute for Molecular Engineering. These institutes are creating an environment that promotes convergence by, for example, organizing space around intellectual neighborhoods as opposed to disciplines, providing seed funding to generate preliminary results in high-risk, high-return areas, reforming undergraduate and graduate education, investing in new types of shared facilities, and recruiting people from industry with expertise in project management and product development. So that's why I think it's a particularly timely meeting to be having this discussion about what can we do to build on the investments that both research universities and private research institutions like the Howard Hughes Medical Institute are making to encourage and promote convergence. So what's the administration doing? Well, in April, President Obama unveiled the BRAIN Initiative, which is a multi-agency effort led by NIH, DARPA, and the National Science Foundation, with a lot of support from private research institutions and foundations to increase our understanding of how the brain works. This is going to require greater collaboration between researchers in neuroscience and nanoscience, synthetic biology, optogenetics, and computer science. And in September of 2011, he announced the Tissue Chip Project, which is a collaboration between NIH, DARPA, FDA, to develop three-dimensional human tissue chips that mimic human physiology. And we hope that this project will improve drug screening, given that animal models are often not terribly predictive of either safety or efficacy of new drugs. OSTP has been convening federal program managers with a shared interest in the engineering of biological systems. Researchers have demonstrated the ability to engineer single-celled organisms to produce molecules like the precursor to artemisinin, which is the most effective anti-malarial drug. But currently, this is a really lengthy and expensive process, and the research community has ideas that could significantly reduce the time and cost associated with the design, build, test cycle of engineering biological systems. In addition to these multi-agency efforts that the administration has been promoting, there are also a number of great individual agency programs that I think exemplify and promote convergence, whether it's NSF's INSPIRE program, the National Cancer Institute Alliance for Cancer Nanotechnology, and the Physical Sciences Oncology Centers. DARPA programs routinely promote convergence because the agency is not organized by discipline. For example, they have a program called CUBE, Quantum Effects in Biological Environments, which seeks to discover whether some biological sensors, like the ability of some animals to detect odors at the single molecule level, are exploiting quantum mechanical effects as opposed to sensors based on classical physics. So I think there's at least two classes of things that the research community can do to help promote and harness convergence. The first is to identify specific compelling challenges and opportunities at interfaces of multiple disciplines. This is what researchers in neuroscience and nanoscience did with support from the Cobley Foundation and other foundations and private research organizations. They made a strong case for an investment in new tools that will enable researchers to measure the real-time activity of neural circuits. One disciplinary community that has done a good job of this kind of opportunity recognition is the Computing Community Consortium, which is supported by the National Science Foundation. They use white papers, research roadmaps, workshop reports, and they have played an important role in catalyzing and informing administration research initiatives in areas like robotics, big data, and cyber-physical systems. And they can also do this in weeks as opposed to years, which is particularly helpful to policymakers. So OSTP would be a really avid consumer of a process or a set of processes that would identify key challenges and opportunities at the intersection of these disciplines, the investments that are needed in research, education, and infrastructure to take advantage of these opportunities, and the potential partnerships between federal agencies, philanthropists, research universities, companies, and other stakeholders. And this co-investing is particularly important in the current environment where agencies are having to struggle with the prospect of the sequester continuing into the indefinite future. The second class of actions that would help promote convergence are really aimed at promoting convergence in general as opposed to a particular instance of it. And so examples of these kinds of activities would include the formation of multidisciplinary institutes, changes in the recruitment, promotion, and tenure of faculty, changes in peer review, both of research grants and papers, education of the next generation of scientists and engineers, including cross-training for postdocs, and additional research on the science of team science so we can have a more rigorous understanding of what types of approaches really lead to more fruitful collaboration. I think one of the instructive findings that we've seen come out of this is that for the first 3 years, teams can be less productive than individual investigators, but then become more productive and creative after that 3-year period. So that's certainly something that research funders need to know about. So to wrap things up, thanks for participating in this important workshop. I hope that you generate lots of high-quality ideas, no pressure. And if you have an idea that you'd like to bring to OSTP's attention, please feel free to get in touch with me. My email address is tkhalil@ostp.eop.gov. Look forward to getting email from all 150 of you. And also get to know Robbie Barbero, who is OSTP staff person who's been working with a number of you on this important convergence topic. So good luck, and I'm really looking forward to getting a readout of the results of today's deliberation. Thank you.